Okay, so if you didn't get a chance to get the notes for climate change, definitely do that because we are going to tear them off and turn them in. That will be your only assignment with this. But let's first talk, before we talk about the implications of climate change, let's talk about what are greenhouse gases. Greenhouse gases are carbon dioxide, methane, and water vapor for the most part. And they trap heat in Earth's atmosphere, and that's a good thing to a certain extent because you have to have it warm enough for life to exist. However, of course, it can accelerate, and with too many greenhouse gases holding in too much heat, it would heat up beyond survivable levels. One of the things we're most concerned about is carbon dioxide, just because we produce so much of it. Anytime you burn a fossil fuel, if you combust any type of hydrocarbon, you're going to get carbon dioxide in water. And so when we burn gasoline or propane or methane or any of that, we're going to get carbon dioxide. Methane is actually a more potent greenhouse gas, holds in more heat. We don't have as much of it. One of the concerns is that the permafrost will thaw, and that methane will thaw and be released and just exacerbate the whole situation. So what we've done is, since 1958, is to start monitoring the amount of carbon dioxide from an observatory on a volcano in Hawaii. So what they found is that a pre-industrial concentration of carbon dioxide in the atmosphere was, right around 280 parts per million, fluctuated a little bit, and has just been going up and up and up at an accelerated rate recently. December 2016, 404.93 parts per million. November 2017, 405.12 parts per million, and last November was reading at 408.02 parts per million. And so what they have found is that today the carbon dioxide is higher than any time in the last 650,000 years. And I want to talk a little bit about that because obviously we weren't around 650,000 years ago to measure this, but how they're able to find out. The scarier thing, the more sobering thing, is that Earth's average temperature is increasing faster than ever before. The 4 hottest years on record were the past 4 years. And we probably think it's pretty funny here in Minnesota because we just got out of this polar vortex, but even the polar vortex was caused by climate change. I'll just quickly go into it, but when you have a big temperature differential between the North Pole and further south, you are able to maintain a pressure differential. And when you're able to maintain a pressure differential, that's when you get winds. And our jet stream is on a certain course, and our polar vortex generally stays up. The winds there stay in the pole. But the more you get closer and closer in temperature, there's just not that big temperature differential between the north and the south. There's not going to be the wind, and the jet stream and the polar vortex can break out of their usual pattern, and that's what we saw, is a break in the polar vortex coming down. We probably will see these things more and more. As we were freezing, literally, we had people down in the southern hemisphere that were having intense heat waves. Horses dying, bat colonies dying, fish dying off. And so we just have to look at the record there. They predict that there will be a hike of at least 2.7 degrees Fahrenheit in the 21st century, which doesn't seem like a lot, but it can wreak havoc and melt global ice. All right. Obviously, we're a big contributor. China is the biggest, but we only are home to about 4.4% of the world's population. So we use a lot. I guess one of the things that would be more political than just the science that I'm talking about is, since we use a lot of it, maybe we're more responsible and China's more responsible than the rest of the world, but that again is something that we can discuss once we get the science out of the way. 1 gallon of gasoline puts around 20 pounds of carbon dioxide in the atmosphere, and you think about how many gallons of gasoline we go through as a nation. The average sea level is expected to rise 1 to 6 feet before the end of the century, and we think about all the billions of dollars in real estate that we have on the coast. That's a little scary. 1910, Glacier National Park had 150 glaciers. I should update that number, but as of December 2016, it was 25. And there's just glacial melt all over the world. The current pace, if we up the temperature, we're going to cause 25 to 35% of plant and animal species going extinct. And that, of course, has an effect on humans as well. Some things that also contribute to it: rainforest destruction. The more trees we can actually plant, the more carbon dioxide they take in to grow and thrive. But when we destroy them and burn them, that just releases carbon dioxide. Palm tree oil, I urge you to look into palm tree oil and its various names. But that's in almost every product we consume. It's in cosmetics, lotions, food, just so many things. And that causes a huge rainforest destruction. So that's something that we could potentially tackle as one thing to find an alternative for. The coral reefs, again, 2016, about 38% of the coral reefs are dying off, and that will just continue. You'll hear a lot of people be climate change deniers, and it just doesn't, the science doesn't support that at all. If you look at all of the sources that I've listed here, any of these sources, you've got 99% of scientists, PhD scientists, saying there is a real problem here and it's humanly produced. And so the people who deny it are just really, I'm not really sure if they have a reason for denying it, or they maybe listen to one or two reports and say, no, this isn't happening. But when you've got 98 or 99% of the scientists saying that it's happening, it's happening, and you can't really deny the science. Now, what we do about it, that's another whole situation. That's the more political issue, but this should not be political. This shouldn't be Republican or Democrat. This just should be human. Some others that you can look at. The science behind it, real quick. How do they know what the temperatures were? How do they know what the carbon dioxide concentration are in past eras? Well, scientists analyze air bubbles trapped at various depths in Antarctica and Greenland. And they have these ice cores dating back to 650,000 years ago, because each winter a new layer of ice is created, so the depth of the bubble indicates the year the bubbles were trapped. And so they can just simply siphon off the carbon dioxide from those bubbles and look at the level. And values have. Since the Industrial Revolution, we started burning fossil fuels, about 1800-ish. It's just skyrocketed. So like we said, really the concentration for CO2 is never really more than right around 300, and right now we're at 408. Current predictions put us around 600 by 2050, and if you think about how old you're going to be at that point, in your 40s, it's weird to think about, but it'll happen, and you'll have children, and you have to kind of think, well, what kind of world do you want to leave or have with your children? So again, the temperatures have drastically increased because of the carbon dioxide levels. We can look at this chart for temperature anomalies. 1880 was a little bit colder, so there was, people will talk about fluctuations. Of course, there are fluctuations, but as you start going up here, there's just an upward, up trend of a positive temperature anomaly. This one is also very telling. You look at, this is 400,000 years, okay? This is probably right around 500,000 years. And you look at, there's some fluctuations going on here, but look at around 1950 and today.
What did I do?
Oh! Okay, so scientists will take air bubbles and analyze them for two isotopes. And, And what the two isotopes are oxygen-16 and oxygen-18. And if you recall with our study with isotopes, that means there are 8 neutrons in the nucleus in oxygen-16, and there are 10 in oxygen-18. So oxygen-18 is heavier, and we are able to take the water, the ice, and analyze how much of each. Now, how do they use this with scientific processing? Well, oxygen-16 is lighter and therefore evaporates more quickly than oxygen-18, and conversely, because oxygen-18 is heavier, it condenses. So as air rises from the equator to the poles, because it's warm at the equator, and it's going up toward the pole, it cools and the water condenses out. And oxygen-18 goes first, leaving more oxygen-16 in the air. In colder times, like ice ages, even the equator's cold and more of the oxygen 18 condenses out at lower and lower altitudes. And by the time the air reaches the North Pole, much of the O18 is gone, leaving primarily O16. Now that's if it's cold. And they're able to measure those levels with current ocean levels and determine the relative temperatures during that era. But as you see, as the temperature goes up, the oxygen 18 levels are going to go up in the polar ice. So the higher the oxygen 18 in polar ice, the warmer the overall temperature of the globe. And in the coldest sites, locations such as Antarctica and Greenland have about 5% less O18 than ocean water. So the less O18 found at the poles in ice means overall colder global temperatures, and vice versa, less O18 found in the oceans and more in polar ice indicates warmer global temperatures. And that's how they're able to tell. So just take some notes on it and you are good.